Autotransformer, a deep dive. The core concept, the secret weapon. The science fiction hook. Imagine a transformer that is smaller, lighter, and more efficient than anything you usually see on the job site. It sounds like science fiction, right? But it is very real. Today, we are uncovering the secrets of autotransformers. The problem with bulk. We have all dealt with massive, heavy transformers that take up too much space and generate significant heat. What if there was a simpler, more effective solution? Unpacking the core. The autotransformer has a secret weapon that separates it from standard isolation units. It relies on a single winding principle. The single winding difference. In a traditional two-winding transformer, the primary and secondary coils are electrically isolated. In an autotransformer, parts of the same winding act as both the primary and the secondary. The tapping mechanism. It works by tapping into different points along that single coil. The input voltage is applied across the entire winding, while the load is connected to a tapped section. Conductive versus inductive. Here is the key technical difference. Power is transferred partly by magnetic induction and partly by direct electrical conduction. Why simplicity matters? This unique design demands fewer windings and less copper, leading directly to lower resistance and much higher efficiency. David versus Goliath, advantages and comparison. The problem. Are you tired of bulky transformers that are inefficient and costly? This device reveals a surprising solution. The heavyweight contender. The standard transformer is reliable, but it is heavy, expensive, and uses a massive amount of copper wire. Copper savings. Because the autotransformer shares a common winding, it requires significantly less copper to handle the same kVA rating. The weight factor. For an electrician, weight matters. A 50 kVA autotransformer is significantly lighter, allowing for smaller enclosures and less space in your switchgear. Reduced losses. With less wire length, ohmic $I/R losses are minimized. The excitation current needed to magnetize the core is also reduced. Better regulation. The lower internal impedance of an autotransformer means the voltage drop under load is significantly less. This results in superior voltage regulation. The trade-off, isolation. We must be clear, because the windings are connected, there is no galvanic isolation. This is why autotransformers are unsuitable for applications requiring full primary to secondary separation for safety. The verdict. When you need a slight voltage step up or step down and isolation isn't mandatory, like stepping 480 V down to 460 V for a motor, the autotransformer is the far more economical and efficient choice. Where they shine, real-world applications. The benefit. Unlock the power of efficiency and cost savings. Discover how autotransformers offer unparalleled advantages in power projects. Beyond theory. Let's see these advantages in the field, starting with their biggest role, the power grid. The interconnected grid. Massive autotransformers are essential for linking high-voltage transmission networks with slightly different voltage levels, such as connecting 132 kV systems to 275 kV systems. Industrial motors. In industrial settings, autotransformer starters are used for induction motors. They apply a reduced voltage during startup, limiting the damaging inrush current and providing a smooth acceleration. The variable autotransformer. For test benches, the variable autotransformer, or variac, is indispensable. Its movable carbon brush allows for a dialed-in AC voltage from 0 up to 110% of the input. Audio applications. In large public address systems, impedance matching autotransformers are used on speakers, allowing a single amplifier to drive many units over long distances with minimal loss. Lighting dimmers. Historically, they were used in theaters for lighting dimmers, providing smooth intensity control without the massive heat waste of simpler resistive methods. Versatility defined. From massive substations stabilizing national grids to the small variac on your workbench, the autotransformer's versatility is unmatched. The economics, cost and performance. The unbeatable advantages hook. Let's detail the cost savings. It all comes down to the copper-to-core ratio. The kVA rating nuance. The cost savings are greatest when the transformation ratio is close to 1. The closer the input and output voltages, the smaller and cheaper the physical unit is. Energy savings. Lower leakage reactance and reduced $I to R losses translate directly to lower electricity bills over the unit's lifespan. A single % of efficiency gain adds up quickly in continuous operations. Voltage stability. Lower impedance means the device is electrically stiff. When a heavy load engages, the voltage maintains its level with less sag, which is vital for precise electronic equipment. Variable output quality. Unlike some modern solid-state dimmers, autotransformers provide a pure, undistorted sine wave output when used for variable voltage applications. Environmental impact. Reduced copper and steel usage also means a lower material cost and a smaller environmental footprint during manufacturing. The value proposition. The autotransformer is a rare engineering solution that is often cheaper to buy, cheaper to run, and better performing in its specific niche. Beyond the basics, the future of power. The future hook. Technology never stands still. How does this elegant concept fit into the future of green and smart energy? Emerging applications. We see autotransformers playing a crucial role in modern energy systems, particularly in stabilizing decentralized power generation. Renewable integration. Fluctuations from solar and wind generation cause voltage swings. Autotransformers are key components in dynamic voltage regulators that help stabilize the local grid in real time. Getty Images. The smart grid. Modern units equipped with automatic on-load tap changers are essential for the smart grid, allowing utilities to automatically adjust voltage levels for efficiency without manual intervention. Key takeaway review. 1. Autotransformers use a single shared winding for both primary and secondary. 2. They offer superior efficiency and smaller size compared to isolation transformers. 3. They are ideal for applications that require slight voltage adjustments without the need for galvanic isolation. Final thought. The autotransformer is a testament to simple, elegant engineering that continues to power and stabilize the most advanced electrical systems on the planet.